Welcome back to the MVP series. Today I'm with Scott, and I have for the first time Quinton as a co-host for the MVP series.
Hey everybody. Hey Scott.
Hello, Quinton. Hi, Yusuf.
I'm super happy to have you on this talk, and I think I should congratulate you for your awesome MVP swag. I really love it.
Thank you so much. It just showed up in the mail, so I'm very excited to be wearing it this morning.
And can you introduce yourself to the community?
Yes. Yeah, so I'm Scott Haines. I've been working in essentially data intensive applications for about 15 years now. Started off as like a front end engineer. Got really interested in analytics and trying to figure out why applications weren't working the way that they should work. And I sort of kind of fell into analytics by accident. It wasn't never something that I really thought about. It wasn't something like they taught. I was in school in 2002 to 2007. And it wasn't something people were really thinking about too much. And so I really got into understanding how the world works through data. And that's been now the passion for the past 15 years. So accidentally fell into something I love, which is great. And now I'm just kind of curious about continuing to find more and more interesting ways of using data to solve problems. Outside of that, I also make hot sauce. So
you might. Wow. Okay, we need to talk about that.
we can talk about gardening as well. It's all little outlets.
And I heard you also write books. Is that correct?
Yes. Yeah. That was yes. That book right there. So Delta Lake Definitive Guide. That was the second book. That one was like a labor of love. Anytime you write something with many people and you kind of converge everyone's ideas into something that kind of reads end to end, it's a lot more of a struggle than if you're just writing the book yourself. Although you have it's like a team or a book family, like a writing family to kind of bounce ideas off of. And also if, you start to slow down on a chapter, you get motivation from everybody else who's continuing not to, which is really kind of fun. Plus it's just, it's better to always have an idea, bounce it off of other people as well. So everything takes a long time. People see books and they don't realize that it's a year and a half of people's life that goes into it. And then that's only just getting the final manuscript out. And then there's months of going back and forth. But you also get there's this whole entire team of people involved in it. All the tech reviewers and everybody else. And in a lot of cases, you meet these kind of long-term, friends, right? It's interesting. The O'Reilly community is a lot the same as the Databricks community. A lot of the MVPs, Adi Polak was helping out with a lot of the review. And she's also just been somebody that I've looked up to, throughout my entire career as well. So it's nice to finally work with the people that, you look up to, and books help with that.
Yeah, it's great. Do you have some metrics on the books? Do you know how many copies have been sold so far?
Let's just say many copies. I don't know. It's it's not best selling because we're giving it away, right? So if you go to delta.io and you scroll halfway down the homepage, it's free. And so with that, every author going into the book knew it wasn't going to be a bestseller, but we still wrote it because everybody, well, I guess I was the only person outside of Databricks who was working on it, but I was really curious about going deep into Delta Lake, understanding the things that I didn't know. And there's no better way to do that than if you're writing a book, because you feel like an imposter the entire time. You're what is that thing that I don't know, that I want to know, that I really don't want to sound like an idiot if I get it wrong? Every time you write something, you're oh, that's probably true. You're wait a second, but is it? And then you go into 2 to 3 hours of research to make sure it's correct. You go all the way back through the Scala code. You go back now through the Rust code as well, making sure that you understand exactly what you're saying. And that's something that you usually you don't get that time on the job. So writing gives you a lot more of that opportunity to, dive in deep. So
yeah, and I feel like it's always a good it's a good way to learn.
Yes.
If you have to explain it to someone, especially in a book, you really have to learn. You have no choice.
Yeah. You also don't get to edit, right? If it's a blog post, you're oh crap, let's just make an edit. It's fine. Let's go back.
For a book, it's much harder to make an edit, especially if it's already published and polished.
You have to wait years. They have to wait for a second edition to get just making minor updates with that. So.
And I remember I was also part of the team who was reviewing the book, and I remember I told them, hey, I think we're now we have liquid clustering, and I think we should really release a chapter about this feature because it's super cool. And then I think Denny or someone told me, okay, we're I think the books have been delayed for 6 months to make sure that everything is aligned and we have maybe the latest features that we can add, because we'll keep releasing more and more.
Yeah. So Tristan got liquid clustering in. That was that was fairly late into the game. It's interesting though, because we started the book in Delta 2 and then Delta 3, and then we're also priming for Delta 4 right before everything came out. So it's interesting because it's there's a lot of stuff changed along the way. So I spent a lot of time talking about partition optimization. That chapter could have been a lot shorter because it would have been let's just turn on liquid clustering and here's where to use it and here's where not to use it. And then, it's almost like a little sidebar where it's and by the way, it's you can use traditional partitioning and optimize in Z order by, which would be great, but hindsight's 2020.
Can you share your your secrets and your tips on when to use it, when to avoid it? You said the order. Do you still rely on the order? I feel
no.
You shouldn't anymore, no?
No. So I think so if you think about the difference between bin packing, right? I just want everything to be clustered as close as possible. I want to fill these files up. I don't really want to have as much data skew. That's only really possible when you don't have directory boundaries. And so with traditional Hive path style partitioning, you're going to always have some small files depending on how you've optimized the layout of the table. And so we had a session earlier this week. We were calling it beyond clustering. And the reason why it was beyond clustering was just because it sounded really cool. But essentially it was more of what's that split point, right? Where it's I have a table, and in a lot of classic data engineering problems, you have a lot of siloed data that you're doing contiguous partition overwrites. And so if you have a lot of partition overwrites coming in, overwriting large portions of the table, then everything you did for incremental prior optimize, whether it's liquid clustering or bin packing optimization, those cost savings, for read go away again. And so you're okay, well, let's just do that whole process over again. So you don't really get that append only and optimize incremental type flow, which is so powerful. So instead it's well, do this not so performant thing for a limited amount of time. Keep that retention window small, almost like a close of books, for a lot of data. And then after that, move into liquid clustering for more of that historic, long-term memory. And so the advice has essentially been contextual. So in the case where you're continuously doing upserts, it can be difficult. You can still do it, right? If you think about write optimization, you can do it in process. Or if you're running a workflow, you can do it as a very last step of that workflow. But in a lot of cases, it's what are you optimizing for? Are you optimizing for an immediate downstreaming customer, or are you optimizing for an eventual future where people may read something? And so a lot of times we internally at work, I work at Nike, and we talk a lot more about when is it needed, right? It's just in time. Can we do things just in time and save the money? Or do we need something to be fully optimized because it's one of those mission critical use cases that everyone needs this data right now as fast as possible? And so you'll make different decisions depending on, what's the SLO, right? And how fresh does the data need to be?
So if you only have append only is kind of simple, I would say.
Yes.
So you're saying if you start having a lot of upsert and updates, that's where it goes tricky. Remind me how, can you do, can we have one flow doing the upsert, let's say, the append and the updates really quickly? And then if you run an optimized in the backend, could you have a conflict?
So
I guess because my thought was, can you do every night, just once every night you just run the clustering option? But could you have a conflict doing that?
So not if it depends on how how the table is laid out. It's if you are continuing to write to date partitions, for example, and then you're clustering within date partitions, you can do something like that. If there's a chance of what you're optimizing to conflict because you have this variable window that you're writing to, then you can't guarantee that a write is going to hit a brand new, table, right? And not a brand new table, but a brand new file within the actual table itself, depending on that strategy, if there's an upsert involved. And so that's the only thing. So it's if you have we talked about like Kappa, like the Kappa architecture. And it's like, you can use some of the same methodologies where it's like, you're writing quickly. You're not really optimizing that as much. Like you could be taking, essentially kind of like snapshots as like a virtual table. So here's my view of that table. And now we can cache this view off for a little bit of time. And there's like kind of one trick to being able to, kind of pretend things were laid out well because now it's fast because it's cached, versus actually having it be, truly laid out correctly, and clustered optimally. But in a lot of those cases, like you're really looking for like read and write like isolation. And if you can't guarantee that isolation, then some of these processes become a little bit more tricky and you'll get like a concurrent modification exception. And if that happens, it's okay, right? Just, it's like regular check and set. You back off, you try again. But, or you just ignore it and you just pick it up the next time. Because eventually you'll be able to make those optimizations. But I think it's difficult too, because like, like I come from like kind of like the streaming world and like streaming analytics and like streaming clickstream type stuff, that's easy, right? Because like I've done something, right? I did some action. Now I'm emitting that. Awesome. I'm going to do other things. It's all part of like a story. And I'm going to collect all of that like as, a sequence of events. And then I'm going to summarize that into something. And, that's going to encapsulate some sort of behavior. And while it's more complicated because there's more things to keep in mind, it's actually a much easier process than a lot of these like, multi-siloed, geo-distributed type problems where it's like, we want a snapshot of what happened everywhere, but we have all these different systems writing to this table. And then you run into like more of like that multi-write, multi-write problems are always, the biggest issue. In a perfect world, you'd have, it's like the game of telephone. And at the very end, somebody's writing on your behalf. Reality is different.
I remember we met last year at the OSS Summit.
Yes.
During the Rust session, like a Rust track. And I want to know like your opinion because I start seeing more and more folks like coding in Rust, and same thing like for Delta community, like more and more people and customers are using some features from Rust to use with Delta. So what are your thoughts about this?
I think it's a great option. We have a session eventually coming up, like eventually like within the next 2 months, where it's essentially like the do's and don'ts of like using Delta Rust. And a lot of that is it's because you're not clustering these operations, because you're fitting this, if you think about kind of classical like horizontal or vertical scaling, a lot of like the Rust like what you're doing in Rust is more of a vertical scale. I'm going to be processing this on a machine versus in a cluster for now, right? That's just the state of like the Delta Rust project. So there's certain things where you would run out of the ability to process on a single machine. And at that point, you want to go back to like kind of the classical, like, Spark driven Delta. But a lot of use cases aren't big data. Like, unless you're working at a gigantic enterprise, a lot of cases in most companies are essentially like shorter bursts of information that need to be, processed as they come through. And so that's where like, whenever you hear like Tyler talking about like the heyday, like the early days of like the Kafka Delta ingest project and now like Project Oxbow, like a lot of that was, we have data in Kafka and all we really want to do is literally distribute that across partitions to a bunch of different like Delta Rust like receivers. And then they're just going to feed it, into a Delta Lake table. It's like, cool, awesome, we got that. If you want to then do a lot more kind of complicated like transformations, then that depends on if that can scale on box. Like how long do you need to keep, that memory around for? Like instead of just thinking about this as a continuous stream, are you processing a lot of information? Do you need to shuffle? And if you have to shuffle because we don't really have like that concept, then you need to go back to like a different type of compute, system to be able to go do that. And so it's like, for a lot of it, it's like, a lot of data engineering problems are I'm taking data from one system to another. And for a lot of those use cases, like that's an extremely simple way to do that. Or if you want to process a lot of things like using data fusion, you can do all that in Box as well. And then it opens up different ways of working. So if you think about like, a lot of like the, distributed systems or systems engineering problems, you could do a lot of like transactional log, processing using Delta Rust on Box. And then you could send like results downstream for further processing as well. And so it's just giving us different ways of kind of mixing, those capabilities. The same thing if you think about like Delta Connect, right? You can connect from different systems outside of like the normal, JVM side, JVM architecture based, processes. and that opens up the doors to a lot of different processing as well. And so Delta Rust for that is also feeding into like what's starting to be kind of like, I feel like it's more right now. It used to be like all JVM based, and it seems like all new projects are all Rust based. And so it's like, it's a very kind of clean, community member for every other Rust project as well. They all are working with the same, it's all basically, it's all arrow buffers and like data fusion for a lot of cases. So that interoperability becomes a lot easier.
And for those who are listening and maybe doesn't know what's Delta Connect, I advise you to have a look at the release notes of the Delta 4.0. Delta Connect is part of it, as well as the type widening and collations and and much more. I always keep struggles to remember all the features we're adding in Delta 4.
There's a large list of them. Type widening is a big one. I think for people that want to not also be in the JVM, sitting in the JVM community for a lot longer, there's a lot more kind of interesting things happening with Delta Connect as well. But that's a good to kind of throw out to, where we're going over the next couple of months anyways with Spark 4 and Delta 4. So
how did you end up being Databricks MVP? I mean, for my case, I think I've been following you for a very long time in Twitter because I was a big fan of Delta before, since I think 2020.
Yep.
But tell us the story. How did you become an MVP?
Yeah. So I also I've not a real good clue on how, I guess, right? So as part of the Beacons program before, it was like the MVP program, and that was during 2020, right? It was like I remember just getting some stuff in the mail. It was like a canvas painting of my face, like welcome to the Beacons, and like some stickers and all this other stuff, and then it was this JBL boombox type thing that had the Beacons B kind of painted on it. I'm like, oh, this is really cool. I'm like, I need this right now because I've been sitting indoors forever, and I'm like, this is nice to get a gift from the outside world, right? It's during those times, and I think I found out later it was because of just it was the work I was doing at Twilio, creating the Spark community and helping to kind of drive that, and a lot of the conference talks and just writing online, a lot of the Medium posts and different articles that were teaching people, and I used to do a lot of different trainings and workshops and meetups, and it's here's how you make things easy. Here's how you test your applications. This is what a pipeline looks like. This is a simple way of doing config driven pipelines and, things like that. And so I have no idea who voted at all, but, I'm really happy that somebody did. Yeah, thank you for that.
I think it must be Denny. That's for sure. I think, but we should definitely ask him.
Yeah, it'd be interesting to find out. I mean, I've been friends with Denny since 2017 ish, right about then, and then, I've been also friends with Jules because they used to run the Bay Area Spark meetup. Yeah. So I had reached out to them about just hosting some stuff, and it's hey, how do I get involved? I want to extend this meetup. At that time, when I was working at Twilio, everybody was on El Camino and Mountain View. And so down the street was Redis Labs, up the street was Databricks. And there's a lot more it's we could just walk up and down this corridor and, basically just do meetups going from company to company. And right in the middle was also Elastic. So it's just hop up the street, and I'm like, well, what if we did Twilio just opened up a rooftop deck, and I'm like, we could use it. And then the pandemic hit. And so a lot of that work happened, and just trying to get it's all the signatures and everything else, all the site policy stuff that goes into opening up the doors to an office. And so it's all right, cool, now we can do the first one, which we never did, but that's okay, that's history, that's behind us. But it did lead to kind of long-term friendships as well, which is cool. So I guess advice for people is if you're curious about something, reach out to people who are running it, right? It's you never know what will happen.
Yeah, and it's surprisingly more easier than people think. Usually, everybody's happy to talk to someone, and it's working well at the end.
Oh yeah, I mean, with Slack, it's cool. Everyone can talk to anybody. But I think it is interesting though, because people usually people assume that no one has the time for them, which is what I found. Where it's hey, do you have 2 minutes to answer a question? It's of course. People have time, or you don't. And eventually you'll get back to it as well. But I think most people, to your point, Quentin, are very much open to helping people. I think those are also, it's good community aspects as well.
I was wondering, can you share a little bit on what you're working on at Nike? Maybe not on the specific of the business, but more like the kind of, I don't know, pipelines you have.
Yeah.
What's going on here?
Yeah. So I mean, if you think about like any kind of like retail e-commerce, we're working on everything from the analytics and like machine learning on like supply chain to understanding more about like it's like where product goes, why, right? What are like the customer, like what types of customers are can you group together, right? Like anonymously. What are the things that I purchase? What are the things that other people purchase? It's a lot like, Nike, not like Nike recommendations, but it's like the Netflix recommendations engines, right? Where it's like, if you think about like retail product as, the same thing as a movie, there's different characteristics of each individual, product, including like fit and everything else like that. And so if you want to be able to go and do a recommendation for other people, it's good to understand whether or not people have enjoyed something and they like something and they've continued to purchase that. And if they do, then it's like, it's a little bit easier to be like, hey, well, we recommend this other thing because we believe you're going to actually like enjoy it. But a lot of those, like those problems aren't like those aren't the hardest ones. So like a lot of like the problems that I do deal with are like, how do you deal with like, potential, like potential issues in like a matrixed organization, right? Like if and I think those are the harder things too, right? It's like, here's like a wild idea. We have a couple people that are on board for this wild idea. And now how do we get that, essentially approved by leadership to move forward as well? And I think those things are kind of fun. I say kind of fun, like it's actually really, really fun to, spawn a new idea and then get people to work on that as well. It's kind of like doing hack days as a career, which is neat. But for a lot of the work, it's just, it's how do we ensure that product continues to get delivered on time, right? That it's what people want so that stuff doesn't sit on the shelves, things like that.
So how do you work as a team? Do you have like many small squad and everybody's doing stuff on data, or do you have one central squad and everybody's relying on them, on maybe some kind of expert, and you can pull the expert based on the project?
So it really like it depends, right? So you have like there's certain things where it's like you have focus groups of people that are always working within like that same domain, right? If you think about consumer domain, for example, like commercial domain, like there's specific things that you need to have kind of like, it's like intimate knowledge of like the ways of working to be able to really excel like within like that, subset of the company. There's other places where like we do have like a lot of like the principal engineers and senior principal engineers will like, we talk about like the Mary Poppins effect, right? They'll go work with like a team for like, 2 weeks to a month, it's like, swoop in, help the team, teach them a new idea, train them in things that they need to understand. If they don't currently know that, or if like they're just kind of getting up to speed, maybe it's, new architectures, et cetera. And then they can like kind of hop out and go help other people as well. And so it's kind of like a hybrid like tiger team for some of that work. We keep on trying different things, right? Where it's like, there's always like more and more and more things to learn to know. And then it's like, education at like a very large company, like for example, like the org that I work in, there's 1,800 people. And so like with 1,800 people, like within like engineering, it's like updating everybody to get, not everyone is going to be completely up to date. And so it's like, what can we automate? Like, what do we teach? What do we train? Like, what do we do as like internal, like meetups, things like that. And so there's like a large effort that goes on, inside that no one talks about. We can't go into details about a lot of it. And you can't really record a lot of it either, but like we have like entire, like we have like a lot of like, it's like on-site, like internal conferences and other things like that as well, where it's more, knowledge sharing and, teaching of like new frameworks, things like that as well. We also do some open source and, I don't know. It's interesting. It's probably like a lot of other companies, right? Where it's like, yeah, we have teams that work on stuff. And in some cases, like they'll be working on the same project for years. In other cases, they'll be working on platform components until those are stable and they'll move from there. Yeah, every day, every month kind of dictates new work anyways, right? And so go with the flow.
And with your, like, I know you have like a very extensive or large experience within Nike, Twilio, and other companies.
Yep.
So what can be your advice to aspiring software engineers or maybe data engineers? Like, how can they be the best, let's say?
Keep learning, right? Like, I think that's like the biggest thing, like that, like for anybody, right? It's, it's like kind of like I think about this thing where it's like it's not necessarily like a mantra, but it's like kind of never settle. Like never settle for status quo, never settle for just knowing what you know, and like always be curious. Like there's no experts, right? Like the second you're like I'm an expert, like you've probably already become, you know, mediocre again at what you are doing. So it's like never stop learning that thing if that's like something that you're passionate about. It's like the same thing with any kind of language as well, right? It's like just because you know Python really well, it's like, do you want to just do that forever? Does it make sense for you to, you know, go back to Java? Does it make sense for you to learn Rust? Does it make sense for you to learn Golang? What are the things that kind of keep you kind of nimble? You know, it's kind of like every time you're doing something different, it's like another kind of brain test. Like I think about like there's an old game for like Nintendo, it was called Brain Age. And just a bunch of games where it's like, you know, it's like solving simple math problems as like things are kind of coming down from the sky, or like, you know, remembering a recipe, and like like it's like kind of simple, like, you know, it's like people talk about katas and things like that for karate. It's the same thing for engineering as well. Like, is there something new that you've learned every week? If you've learned something you think it's exciting, can you teach it to somebody different? You know, can you write about it? Like, is there something that you can do to, like, you know, spread that kind of joy of something that you've learned as well, and kind of spark curiosity for other people? I feel like with that, like a lot of it is like, you know, just continuously doing that, right? There's always something new to learn. And that can be applied anywhere almost.
Are you using AI for these kind of learnings? I feel like now, you know, sometimes I don't know how to do something. I just ask the AI and I'm like, oh shit, we can do that. Wow,
Yeah.
nice.
I have a love-hate relationship with like Copilot and like other like immediate information retrieval. I feel like it's like, all right, I will use it after I've burnt myself out trying to find something. Because I feel like it's, I don't know, I like type ahead, right? And I'm like, okay, it's just type ahead, but it's type ahead that understands exactly what I want to do, and it's predicting what I want to do in the future. Like the joke is always like, it's like, I'm going to go write this code, and it's like tab, 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 I'm done. Like that's good and bad. Like I feel like if I had, and I don't know if this is like, if this is going to come across correct or not, or like politically correct or not, but like when I first started off, like early on in my career, if I had something like, you know, Copilot, I don't know if I would know as much now, because I wouldn't have to. And I don't know if that's a good or a bad thing, right? It's like, you know, if you need to understand, like, you know, just kind of basic architecture of what an application should look like to be able to describe what the application design is to like an agent, like if that's like where we're going in the future, there's going to be a lot less, like it's going to be more of like, you know, it's like, here's my application black box. Like the agent understands how it works, what it's supposed to do. I've given it a couple like, you know, parameters to work within, and now I'm kind of hands off. I think I'm just kind of old, and I'm like, I don't know if I want that. I like to know how things work. And so it's like, I don't know. I think it's really good for like, you know, automating PRs. There's a lot of different cases where, you know, if people are all busy and you want to have like a second opinion, it's good for second opinions. And then in a lot of cases as well, right? It's very, very good for understanding how to teach you how to optimize something that you might not have thought about as well. So if you're learning new languages, etc.
Yeah, I agree.
Much
I
second
feel like
opinions can be good.
yeah, it's super good for reviews. I turn it on the demos that we have, and when we do a commit, it's like, hey, are you sure that's what you want to do? And then you're, oh shit, like maybe
Yeah,
not.
maybe not. Maybe I should go back and think about that again. But I think that part is good, right? It's an unbiased conversation as well, whether it's biased or not. Like you're not thinking about it as like a human, and sometimes people don't want to hear certain things like during the time of a pull request. It's like, hey, this could have been optimized better. You know, this isn't as testable as it could be. And some of those conversations, like they're good. Like you have to have them because that's how everybody learns, right? To, you know, write more performant code, write better testable code, more maintainable code. But I feel like having a computer do that for you is great, because you can't really yell at Copilot and be like, you don't know what I was trying to do. It's like, yeah, but I don't know. This is what I think you should do. Like there's no, like that human part goes away, which means that it's more objective, which is, I think, better for a lot of that. Because I think subjectivity ends up, you know, being the heart of a lot of like, you know, elevated conflicts like within companies.
Yeah, that's right. Yeah. At least you can get, you know, all the feedback, and that's, you know, just the truth, and that's it.
Yes, that's all we're searching for.
And I feel like it's like You mentioned an interesting kind of paradox. So I feel like now the AI is going to be, maybe in a few years, like it's going to be able to do most of the, I would say, like the basic coverage engineering job, most likely. And then I'm still like, I think we still have, many years where the human is really going to excel on very specific advanced tasks.
Yes.
But I feel like to be able to learn that and become that kind of expert, you have to do yourself all the average stuff and learn, the basic first. But now that it's done by the AI, it's like removing you from the need to learn that. So I wonder if we would have a shortage of really kind of principal software solution engineer in the next few years because of that.
I've actually read I've read a couple different articles like on that. It's like more of like it's like that future facing what if in the future type thing. And a lot of it it's like the conversation usually goes you have somebody who's like a classic kind of like software architect, data architect, etc., who is now filling in the parameters for the system, but usually that's people who are like, like my hair is not looking super white today, but like it's usually people who've been like in the job prior to a lot of like the AI and everything else like that, right? Like we all had to suffer back in the day, right? We didn't have debugging tools like we do nowadays. Like it's a lot of like those lessons learned. People will still have to learn them, to your point, Quentin. Like if they don't learn that, then it's going to be a lot harder in the future. Like my generation ages out, right? And like we retire. That's okay, right? That's a natural part of the life cycle of everything. We still like you still need to have like the knowledge experts in to be able to then like assist the systems. And then eventually, the systems will be like, we don't care, we're going to do it our way. And you're like, okay, well, just don't spend too much money. Right. And it's like, all right. But I think for like the years to come, like that's going to be a thing. I wonder more about like, I don't really see like a lot of like, it's like human rebellion coming from this, but it's sort of like, how do we kind of change like, people's perspective on like, what's good and bad, right? Like what's the right way to do certain things? Like I think about like, if I can like auto root analyze a problem because I have like an agent that can look through logs, awesome. That's so great because I don't have to do any of that work. I can't be everywhere at once. Like if you're debugging things like in Kubernetes, there's a lot of different pods to look at. There's a lot of problems that could happen in like a large distributed system. Being able to automate a lot of that, like search and, it's like kind of the old search and destroy mentality, but in this case, it's like search and analyze. And, then can I automatically, reconcile that problem in a specific way, whether it's, an automatic, pull release to a specific, code base to go fix the problem that can then go get released automatically if I approve it, or if it just decides to approve itself. Like, I feel like there's certain things that it's more of like that kind of classic toil work where it's like, I don't want to do it. I don't think anybody else really wants to do it either. It's like, can we get rid of that work? Because like a lot of like, if you think like not just like systems design or anything else, but like pipelines, right? A lot of like the work in pipelines is like, it's like, oh, something broke somewhere. Let's go find that. And let's go optimize this pipeline to go and not have that problem happen again. And in certain cases, it's like, if the same thing's happening over and over and over again, and somebody has continuously, fixing those problems and or just like, recovering from those problems without fixing them correctly, it would be much better to have a friendly assistant, an agentic assistant come in and be like, hey, by the way, did you know this? Here's your new code base. We fixed it, or we fixed this pipeline. I think that's a lot like, I don't know, it feels safer, right? I don't know. I think I also just don't want to like give up control either, right? So I think it's hard for me. So, but I think as we get, as we kind of get, further into like this, the new world we live in, I think more people are just going to be accepting that, this is part of how we do everything, and, how do we work better together, with our robot overlords.
Indeed. And I think just before what you've said, I remember like just 6 years ago, I had to go to Stack Overflow whenever I was coding in Spark and facing a problem. And I would spend maybe 1 hour, 2 hours in Stack Overflow looking for someone who posted the same question, understanding the response, and go, while now you can just copy paste the log.
Mm-hmm.
But I think it's also taking an abstraction, because now people doesn't analyze, and sometimes they take what the LLM is responding for granted, or maybe it's as the correct answer, which may be wrong because it depends on the source used for this specific response. So it should always try to deep dive a bit before taking for granted the response.
Yeah, but I mean, it's always been the case. Like people have been on Stack Overflow just copy pasting stuff. Do you trust what you copy paste? Do you even understand? And now just giving you more of Stack Overflow out of the box. But I guess it's the same issue at the end.
Yeah, I agree with that. Like I think though, like I think it's interesting, right? Because I think it was maybe it was like 2 years ago or so. A colleague of mine, like a Ashok, was going through. This was prior to Spark 3.5. Prior to like having like protobuf, like the from protobuf and to protobuf, we're looking at creating like a protobuf 3 expression encoder. And so we asked ChatGPT, it's like, hey, can you put together an expression encoder for protobuf 3? And it was like, it took maybe an hour and a half of like fiddling to fix everything to make it work. Which I was really, it's like, this is awesome. But it was also giving us like, it's like, here's how you would use it. And like that stuff I think was really cool because like with a lot of like the kind of like, deep in like the heart of like the Spark ecosystem, a lot of times making complex changes are very, very difficult given like the size of the code base. The same thing can be said for like the Delta code base as well now, because it's getting larger and larger as like the project continues to have new features. Like being able to like quickly get to where it is that you would need to look to go and solve something, I think is also an interesting like aspect as well. So whether or not it's the Stack Overflow effect, but using it as like a really, a deep, smart search engine for code is also really cool.
Yeah. Search learning engine. I agree. Cool. Well, Scott, thank you so much.
You're very welcome.
To have you. We're waiting for the next book. Maybe an iceberg. No, that one is already done. Maybe a new one.
We'll see. We'll see what comes in the future. The idea comes back and forth many times. It's like, is it worth the effort? Is it not worth the effort? Is it a good idea? Is it a bad idea? So we'll see what happens in the future. So
perfect. Thank you so much.
Cool. See ya.
Thanks.
Bye, everyone.
Bye-bye.